area. See, that's 500 meters scale. And you'd think, why would somebody take so long to map these rocks? Well, they're really complicated, and it's kind of hard to get around, as you'll see. And so this is the Washita Valley Fault coming this way, and it keeps going that way. This is a smaller thrust that comes off it. The gate for the fence, the gate is right there we went through, and that's the road we're driving up on. We're right at the crest here where the towers are. And so you see some stratigraphy here. Ignore those faults. We don't understand them. They just bother me. This is our lower rhyolite flow in the orange. That flow is a minimum of 300 meters thick. The base is thrust faulted against the Arbuckle Group over that way. So that's our lower rhyolite flow. The little blues there is a sequence of volcaniclastic rock, conglomerates, sandstones, rhyolite conglomerates, rhyolite sandstones, a lot of vitric tuff. That section's about 60 meters thick. I think it probably represents a lacustrine setting because it's got all these really beautiful fine-grained, delicately laminated ash beds. They're tough. Now, kind of hard to preserve those. I suspect it fell into a lake. And then all this orange is our upper rhyolite flow, the 600 meter thick flow. This is the base here. We can see the base of the flow in a couple places against the underlying volcaniclastics and tuffs. And so we know that's the base. Those of you that go on the traverse, there's some very interesting features right at the base that we'll see. We'll be able to walk up section. We can see a nice basal chilled margin. We can see places where the lava interacted with the lake sediments while they were still wet. So you get a mixture of sediment and lava together, which we call a pepperite. We'll see that. We'll walk up. You can see how the textures in the lavas change. The lava changes as we go up. All these arrows are the plunge of columns. They're very nicely developed columnar jointing that is perpendicular to the base of the flow. The dips here are about 45 to the southwest. So if you look at this place here, you're seeing a section through that upper flow. It's a minimum of 600 meters thick because this is an erosional unconformity against the upper Cambrian Reagan Sandstone. So this flow is somewhat thicker than 600 meters, but in one place we start getting to its chilled upper margin, which was originally glass, so it's probably close to the original margin. Now the uranium lead age that Bill Thomas and Tim Dennison collected is from our GPS coordinates coming from this little body here. And the other thing I want to just briefly mention is we have these two major lava flows dipping to the southwest, and then you see all these blobby things. The ones in purple, whatever that color is, that color there, bluish thing. The pink ones here, there's four major types. They're sub-volcanic rhyolite intrusions, hypabyssal intrusions. We can map them out. They're clearly intrusive, and one of the reasons it took us so long to map it is there's no rhyme or reason to them. You know, you just got to walk around till you can see them. And so there's a lot of them. I think we mapped over 20 separate intrusions. There's 4 different textural and geochemical types. And this is quite unusual for other parts of the Carlton Rhyolite where we've mapped. We usually don't see these. And there's quite a lot of them here. So that suggests to me we're probably proximal to some kind of vent setting or proximal to the magma feeders or something, because when you get to the Wichitas, you hardly ever see these. And so according to the GPS coordinates, your zircon sample actually comes from that. It doesn't change your story at all. It's just a sub-volcanic intrusion instead of an extrusion, but it's part of the Carlton Rhyolite. I'm sure these are genetically related. Now these sometimes coarsen to the point you can actually see the grain size a bit, so you could call them microgranite if you wanted to, but they're so fine-grained I just prefer to call them rhyolite. So that's the